let's give it another minute. We are almost full house, but just want to make sure we have everyone as we kick off. How many of you are currently Couchbase users? Could you raise your hands? 5 or 6. Anyone on Couchbase 4.0 trying, prototyping, anyone? 2, 3, 4 people. Couchbase 3? 3.x? Okay. Okay, good. Helpful. Feel free to stop me as we go along. All right, let's get rolling, actually. So I'll talk about the use of Couchbase within Symantec. Symantec, as most of you know, does a lot about security. So the brands right from Norton antivirus to network security, email security, endpoint security, mobile security. So it's about security. Previous, till not so long ago, it was security and storage combined. The company split. The focus is on security. I'm the CTO for enterprise security products. There's a similar group, consumer security products, which does not have a CTO. So, to give some idea of what Symantec does, we have threat protection, which is about preventing the burglar from coming into your house. So we stop it at the network layer, at email. 70% of infections come in through emails, some way of social engineering. Email, then there's hardening, which is looking at these are blessed connections. Say Ashok connecting to Ibrahim is a blessed connection. It's happening like a Tomcat reading its config file. So zero-day attacks can be looked at from behavior, but hardening policies can greatly prevent zero-day attacks. Network security looks obviously a wider spectrum. It's not as deep because you simply don't have as much time. Just a little mental jog for everyone here. If you think of a 10 Gbps appliance and the average packet is 200 bytes, let's try to work through the mental math. How many packets? About 50 million packets. If you have 500 processors, do I need to repeat, or did people at the back hear fine? It was reasonable. I'm a loud voice, so thank you. If you have 500 processors and 50 million packets, it's a lot per packet. Per processor, you're queuing up a lot, about 100,000. You don't have very much time in the network appliance. So you do the best effort broadband thing, and network appliance cannot give you everything. Take, for instance, most of us here. You're not going through the network appliance of your company. You're sitting here connecting on a Couchbase Wi-Fi or tethering out. So network is a broadband, endpoint is the endpoint, then emails. That's the threat protection. That's keeping the burglar from coming in. How do I prevent the burglar from going out with the data? DLP is about data loss prevention. It prevents you from copying it out onto USB sticks, prevents you from emailing it out over the network, computes rolling hashes on the documents. So you cannot take the document in two parts, two overlapping parts, because it's got rolling hashes and says, nope, this looks like you're trying to smuggle the document out. Encryption, tokens, etc. As we think about these are the protection technologies, then how do I apply policies? What happens with policies is typically you will respect the topology of the policy. There's a reason why I'm bringing this up before the Couchbase, so you'll see the use case much better. So say it's an OpenStack environment. Then we are probably talking about apply this policy to all this, to this entire network segment. Say if it's AWS or Azure, you're going to apply to a security group or a subnet or an availability zone. It's the semantics. So typically, the policy finally has to trickle down to that endpoint as a policy. But you don't configure hundreds and thousands of nodes. You configure in units which respect the topology. So with that as a backdrop, the topology is what we put on Couchbase. So the topology is very, very highly read. It is used as context to interpret events, to interpret policies, to cascade policies. So it's a very high read, reasonably high write. Okay? So, and we go across all the platforms, everything. One important thing, this is an aside for this talk, the adversarial learning system. So most of us, when we talk about machine learning, we think of recommendation systems from Amazon, Netflix. When you buy stuff on Amazon, you're not buying in a way to fool Amazon into believing that you like things you don't like. You're not watching movies on Netflix to fool Netflix into recommending the wrong movies to you. We have a different situation for Symantec. We have adversaries, active adversaries. So the learning system is not a very passive, simple classification. You have to take into account the adversarial behavior. That point is not super relevant to the Couchbase part of the discussion. What happens effectively? Some kind of REST router, highly available, and you're going to, let's see if I can move this around. Yes, I can. So REST router, highly available system, all the devices, all the endpoints, everything talks to this. It's a highly scalable system. It's not humans, it is machines informing you, I saw this file. I'm trying to connect to this IP. Is there a risk? Is there a reputation risk? So it's very large. How large? Most of us think when Walmart does billions of things, it's very large. Billions of people or millions, hundreds of millions of people, it's very large. Most of us hopefully produce more files than babies. So it's a very, very large number of files. The file reputation is orders of magnitude more. Files, IPs. IPs are switched around. For an active hacker, you sell the IP and buy a new block of IPs because you don't want the bad reputation to prevent you from hacking in. So there's a lot that happens. So there's some kind of asset topology which helps us interpret events. That is where we put in Couchbase. So I threw this slide in right at the last moment. How do we think about databases? If you think about databases, you are talking different families of databases. You have the traditional relational database systems, Oracle DB2. Then you have MySQL, MariaDB, Postgres. Relational database gives you a SQL front end, typical, traditional, ACID-compliant relational back end. Atomicity, consistency, isolation, durability. Everything's about trade-offs. KV store. So underlying, you have some kind of a B tree for all the indexes. KV store, key value store. You show up with the key, fantastic, you get the value, bingo, right away. You don't show up with the key, hopefully you have a secondary index elsewhere, otherwise it's a little harder, but it scales much better. The key thing, ground up distributed system thinking. So if you look at, say, Oracle DB2, actually, an interesting aside, one of the best hints I can give sometimes to people is, if you tell people it's hard, they just try to work harder around it. One of the best hints sometimes is, imagine that it's infinite, the volume. Then people start to think in the data structures and algorithms and techniques which actually map better to the problem. So from Oracle DB2, because they're big, people don't typically think of splitting it up, don't think of sharding. Let's fight and grow more and more and more. It's a scale-up model. With MySQL Postgres, you think of some degree of scale-out sharding. Because it's too large for MySQL, and that is a healthy thinking pattern. For key value stores, ground up, it builds in the sharding. How many of you offhand know consistent hashing? Some of you do. OK, a little bit. Do one of you want to take a crack at explaining consistent hashing, or should I just do it?
I can do why you use it, not how it's implemented.
OK, go ahead. I'll
Consistent hashing is the way, if you change the players that are being hashed to, when you rehash, you're not moving around the hashes to it everywhere. Like they
Good.
stay some stickiness.
Some stickiness. So imagine, good explanation. Imagine that we said everyone in this room is going to disappear in 20 seconds. You've got to go to another of the other 3 rooms available. If all of us try to independently make the decision, it's complete chaos. So what you end up doing is bucketing. You may go 2 rows here. You are bucket 1, the next 2 rows bucket 2, and we have 5 buckets, and we make, that's one part bucket allocation. The second piece, which bucket goes where? Consistent hashing in a ring formation. It was too hard to make the circular pictures and everything, so I'm going to try to wave my hand and try to explain. In a ring formation, you map the keys and the values. And the rule is very simple. You map the keys and the nodes. Every key snaps to the next node. If this node disappears, everything in this range snaps to the next one. So there's a very clear place where every bucket goes. And what does it ensure? Actually, we bucketize many more ways than we have nodes. To give an example, you have 1,024 buckets, maybe a 3-node cluster. So what's happening is that if a node dies, it has 1,024 buckets. Most of them, it's just, say, 516. If it's a 3-node cluster, 516 go to one, 516 to the other. If it's a 5-node, the impact of a node crashing distributes beautifully. Did that make sense, or did I lose people? If it didn't, shake your head from side to side. I will notice. Your neighbor won't. OK, no shaking head from side to side. Very good. So this works very well ground up KV stores, distributed, large scale, consistent hashing. Also, actually, I forgot to mention, of all the systems, does exceptionally well in cross-data center replication. And now with Symantec kind of situation, you need data here, need data there, all kinds of replication rules, because we are getting sensitive information. First, you have to do some anonymization. Then you have to respect all kinds of things. So document store. Now, moving on to document store. Remember, I talked about the front end of the database, which is your pretty SQL, which you interact with. Then the back end of the storage engine. Insofar as they map reasonably well, it's beautiful. When they don't map, it's a little harder. There's some conversion, some magic going on, and you will pay for it in some performance points. So Couchbase plays in the KV store because Couchbase had the mem-base, memcache lineage. Couchbase happens also to play in the document store because it has the CouchDB document facade. So flexible schema, that's the big thing. I can add a column without having to do a lot of work. Flexible schema. And good query primitives which respect JSON typically. So Couchbase does well there. Typically graph stores where it's an unknown number of joins. So sometimes people say, oh, a employee department. There's a relation. I should just do a graph. Not necessarily. What I find useful, in a graph store, the traversals, the joins are very well connected. In a traversal, if there are unknown number of joins, graph stores are unusually good. That's one place where I find it unusually good. Otherwise, the other stores should definitely be considered well. The columnar store is more about columnar compression. You have pre-joined, pre-aggregated, compressed the data, and it works well. This was a general database landscape. Was that helpful, or do you want me to jump closer to Couchbase? OK. Any inputs? Welcome. A brief bit about messaging systems. We have obviously large messaging systems. Database is not usually a great messaging system, by the way. Any takers on why? Take a guess, even if you're wrong. Be brave. Okay. Availability? Database you'll have to keep available, but yes, it will affect database availability if you start putting messages. Round trip? Round trip of read-write, too much I/O in the general direction. Software is all about trade-offs. Everything is about trade-offs. The I/O, are you more reads or writes? And that trade-off will determine everything about architecture. The hardware is giving you what it can give you, right? So in relational databases as well as key value, you're expecting a lot more reads. Probably 95% reads. Really focus on the reads, speed up the reads, and some writes are happening. While messaging system is peculiar. If you have transactional, I enqueue a message, and then someone else in the next dequeues it. What really happened? I insert it, you delete it. Probably a read. That's a 3333 insert, read, delete, insert. That's like 67% write. No database really optimizes for that. You are optimizing it for database design internals, the storage engine. It's all optimized for the read. So at low scale, sure, everything works. But at high scale, this is not a good example. You will have to move away. If you're doing a startup, it's fine. Start with it. If you become rich, you will need to get out of abusing the database. Made sense? All right. So one brief bit. The reason ZeroMQ, actually for any benchmark, take a look what it really stands for. The reason ZeroMQ is so low is because it's just a socket routing library. It's not actually writing anything to disk. To have an order of magnitude on numbers, if you think of disks, 7,200 RPM, or 6K RPM will give you 12 milliseconds just to rotate once, 12 milliseconds. Flash will go sub-milliseconds, single digit to sub-milliseconds. Round trip to Amsterdam from San Jose. I know San Jose because I lived there. I don't know New York. Round trip, probably similar. San Jose, 150 milliseconds. Not very large numbers, but what about the processor itself? It says gigahertz, so it's in the order of nanoseconds, 10 to the power minus 9. The L1, L2 cache, again, if it's pipelined properly, it'll be nanoseconds. Memory, microseconds. 1/10 of a micro. Then flash, 1/10 of a milli to a milli. Tens of millis hard disk. So now when you've got the spectrum, you know already, if I cut the disk writes, I can scream in performance, orders of magnitude. So most benchmarks, when you look, just check whether it's writing to disk or not, and how many disk writes. To give some thumb rule, imagine two-phase commit. Do you guys know two-phase commit reasonably well? So you write on the resource, you write on the coordinator. If you do two-phase commit, I'm doing 3 writes, probably 3x speed penalty. So how many disk writes? The rest of the CPU, very little is happening in processing unless you're doing scientific computing. So messaging, I will skip through. The Couchbase ecosystem, diving a bit deeper into Couchbase. KV store, that's how we started. Document store, that's what we're using. Longer term, I like the syncing and embedded database. Maybe we will think about something in the appliance, etc. Okay? Something at the endpoints at some future point. We currently don't use Couchbase for that. Like the general admin console, by the way, I stole a couple of these slides from Perry Krug, who works for Couchbase. It's just easier. The pictures were pretty. So, online upgrades and operations, built-in consoles. In general, this works out well. And I think the biggest one is multi-data center distributed. Couchbase does async writes. So remember we talked, it's all about the trade-offs. There is no magic. I wish there was. So in the trade-offs where Couchbase played, was async writes to disk, async writes out to replicas within the same data center, async writes out to across data centers. Okay? So you batch it up. Why is it safe to do async writes? The reason it's safe, if you had only one replica, it's not safe. That replica goes down. You've lost your write. If there are at least one other replica, the likelihood that both crash without propagating it out to disk is very low. Make sense? So typically, 2 or 3 replicas, all of them crash when there's no common reason at the same time without writing any one to disk is very low. But this allows it to perform extremely well because you give it a write. It's not, remember what we talked about, 10 to the power minus 9 for processor, and then millis for disk. So what can I do? Yes, please, go ahead.
Do you see any use cases in your work where direct I/O is needed?
Some cases you can, by the way, you can change the settings.
No, you can change it.
Yeah.
Nobody does, right? I mean,
In general, no one does.
logging is perfect for direct I/O, but who doesn't?
So write-ahead logging is perfect for direct I/O. You're right. In general, we don't need it for most of the things. Fair enough. Go ahead.
Did you change from something else to Couchbase for this, or is this a new?
This was a new project. So typically, for anything where you're replacing, it's not that we rip and replace just. So we look at technology, and then for the new or the cycle where we would have to rewrite anyways, we will then throw things in. Otherwise, it looks like pure CTO adventure. So I think one of you were talking about the sharding. So a bucket is a logical unit of residency. So we move this bucket. There are many of these buckets. That's a unit of data replication, unit of server residency, multiple buckets within a server. Then there are copies, replica buckets on some other servers. It's not like every bucket in my server has a replica on, say, one other server. Some of them have here, some of them have somewhere else. It's distributed out. Typically, data 1024 buckets, statistically 1 by 1024 in one data set within the bucket. And this is kept track of in a cluster map. That's how Couchbase works. So write-ahead logging, incidentally, was not quite the same way in Couchbase 3. Couchbase 4 does a lot better, and we will go into that in a bit. So cross-data center replication, again, replication queues, and this works really fast. Remember the use case, lots of reads, because this information model, remember we talked about the information model and topology to understand policy, to understand criticality of events. The same thing happening to, say, someone at the lowest level of the company versus the CEO are very different. The same hack being targeted because the impact to the company could be very different. This topology is very critical. One other thing which I liked, the ecosystem support. Everything can be built with enough time and money, but I still want for the same money some things to be built beforehand. So good news, the ecosystem of Elasticsearch to Couchbase, there's a good plugin that worked out very well. Our events, typically what's happening, the end user administrator wants to search. You will need an Elasticsearch unless you try to bundle a Splunk inside, which is expensive. So you will put in Elasticsearch. If you're going to have Elasticsearch, then I want to convey it over to the other data center. How do I get all the Elasticsearches in sync? Because otherwise you search here, you get one set of results, you search there, you're told something completely different, and that's not going to work very well for the IT administrator. So the underlying substrate, we layer the Elasticsearch Couchbase, and then imagine another one in another data center, and the Couchbase to Couchbase connector does the cross data center. So it works out well. We don't have to do anything or worry about it. Couchbase to Hadoop. Anything, as it gets very large, we want to, you will want to store in the big data systems. You will want to do pre-joins, pre-aggregations. This system that I described is the OLTP, the live system. You're going to look it up and decide inline, should I be stopping this? Should I be killing that process? Those kind of thinkings. The OLAP system, the analytics platform, is so that we can do deeper machine learning and look at the incidence of this file, how does it correlate to infections on the machines. And you're going to often join a lot. These are batch operations. You will need to pump it to Hadoop. The scoop adapters work out well. So these are ecosystem brownie points. Sure, you can do it by hand, but you have to write it, and the less fun part of testing it, performance testing it, all that kinds of stuff. So for us, very important, scalable reads very fast. This is Couchbase 3 version 303 actually. Operational simplicity, cross data center replication, very important to us. Consistent hashing, one node dies, it's not a drama situation. It's not a high drama, high voltage. It's like, okay, rebalance the nodes, we'll get it up, we'll throw something else in. The plugins, Elasticsearch plugin, scoop adapter. We did not use the secondary index and async indexing. So the secondary index in 3 was async. It had a map reduce, which would try to update the index. The problem with the model in 3, which is fixed in 4, was that oftentimes, imagine I've inserted something, okay? In the index, it hasn't showed up. Your query hits the index and asks, hey, is there an incidence of this virus here? You say, nope. They go away. But actually, there was. And 2 minutes later, it'll show up. That delayed indexing and giving a process, a machine or a person, a false sense of security was not something we could afford. So we wrote some stuff to make it synchronous. So in general, for most database systems, you'll try to update the index first, because at worst, you'll get a dangling pointer where it says, oh, this data is there. No, it's not. But you don't send people away saying it's not there when it is there. So did that make sense? Scoop? Oh, Scoop is connecting you to Hadoop. Oh, okay. So it's a good adapter which gives you a plumbing to Hadoop. Elasticsearch is plumbing to Elasticsearch. Yes, someone else had a question?
You said in 4
they fixed it, yeah.
How?
So what they do is inline, and you do just-in-time aggregation in some of these. So it works out better. So we haven't moved to 4. We'll evaluate some more. But in general, the direction looks very promising to me. That's what yes?
With the Elasticsearch, is that for searching the data or searching like the audit log?
No, this is searching the event data. So there are 2 types. Very good question. There are 2 types of places where you use Elasticsearch. One is for our operations team, keeping our cloud services up. Are the machines running fine, not running fine? That's like the traditional Splunk, our operations log, where you call the elk stack. That is one. This is more inside the product. So this is multi-tenant. For company 1 versus company 2, your searches will never pull up something of another company's. It's the data search. It's the security events. Okay. So in general, these are the reasons why we found it beneficial. We did not use the secondary index. What do I like about Couchbase 4? Simplifies code, much more maintainable. Write-ahead logging, scale-outs. You can put more query nodes, more index nodes, more data nodes. Why is this important? Actually, index is more valuable than even the data. If you have to pick between one or the other staying in memory, pick indexing. Let me give you one example. This is probably an RDBMS example. Imagine a B tree, 7 levels deep. It's a lot of data. The first 3 levels can stay in memory. The next 4, you're going to hit the disk. So essentially what you end up doing is 4 hits to the disk to find out where on the disk finally it is. Out of 5 hits to disk, 4 were on the index. So if the index starts spilling over to disk, it's bad. So the ability to scale this out correctly is valuable to us. Global secondary index, federated query, just-in-time aggregation, allows a few things. And ForestDB at the storage engine layer gives us sequential append-only logging, write-ahead logging. Copy on write, and leverages the parallel channels of SSD. So it works out well. Nickel, the query language, we did not have access to Nickel when we wrote the code. Whenever we look at it next, post-upgrade at some point, simplifying this, vastly simplified query semantics, looks like SQL. So RDBMS, you ask, I want this, and then magically the database engine figures out the join order, the where clause, which one comes first, next, histograms, all kinds of magic. In key value stores, you didn't have it. This is good. The SSD optimizations, what do I like about it? This is not something most people talk about, but this will take some time because all the features may not be leveraging everything right away. Not everything is on the Forest storage engine. SATA drive, 7,200 RPM, say, 15K was the highest, 120 IOPS. Look at the IOPS jump, 120 to 39,500. Look at the other weird thing. Disk blocks are 4K, 8K for read or for write. Flash, you can write 4K, but you erase 512K. There's a bit more. This asymmetry is pretty massive. You're going to have to do things very differently. And Flash also wears out. So the usual garbage collection, I will take this away, compact it, and put new blocks. Not that easy. You're going to take this away means you're going to have to copy these somewhere else. You're going to have to erase this. You have a limited number of these erasers after that. So how do you wear the Flash uniformly? How do you avoid write amplification? So sequential append-only log minimizes the write amplification. Write amplification is, I wanted to write one thing, but because of the fragmentation, did the controller at the Flash layer write more times all over the place because of fragmentation or garbage collection? So you want less write amplification. The next thing, yes?
It's worth noting that they've published an open source tool called ForestDB Benchmark.
Oh, they have.
Yeah, and we use it at Intel, and we open sourced a web app on top of that called DriveBench.
Very
It
cool.
allows you to compare ForestDB, RocksDB, LevelDB, and WireTiger.
Cool. Very
And
cool.
We're able to get almost 1 billion documents on just one SSD.
A billion what?
1 billion documents across 8 to 10 instances of ForestDB.
Wow.
running on a
Very,
single
very
SSD.
cool. Very cool. So this, I think, is actually less spoken about than the secondary index, but I think in the long term, this is a more sustainable value proposition. This is very cool. I did see some things of the work with Intel, and it's very impressive. The parallel channels for reads also looks promising in general. So Couchbase 303 were picked for those reasons. Couchbase 4. OK. I think that was, let me just go back to the conclusion because I didn't end it too resoundingly. Not that there is anything resounding going to happen. So Couchbase 4, so Couchbase 4. Convenience, like Nickel, simplifies. We don't have to write a lot of custom code declarative. Like the global secondary index, which we have already coded around. But for future things, we will use secondary index once we move to Couchbase 4 with adequate testing. Storage engine, the write-ahead logging and SSD optimizations allows us to think more positively about the whole thing. Operations, I like the new thing of multidimensional scalability. Query, index, data, scale differently. It gives me more Lego blocks to play with. Questions?
You mentioned earlier about the indexing lagging behind. So what did you guys do to address that? You mentioned going synchronous, and did you even go as far as writing your own index?
We wrote our own
In
index.
advance of writing the data?
We wrote
So
our
you
own
dealt with
index.
the application.
Yeah. In our application, before you write the data, you write the index, then the data. So that's what we did. So, but this is good. I mean, every time you write these, sure, it's fun to write it the first time, but you have to test it for all of eternity. You have to test backward compatibility. The fact that it's composted down also layers it more correctly. My teams are more security. Our job is not to build a database, security focused. We do it when we have to. We build security software. Questions, anything else? It's a lot of data. And you can imagine with the number of files, number of IPs, number of actors, cookies, VMs, the same machine. Even if I sell you the machine, the entire characteristics of the machine have changed. So we pick up little clues across the board. It's a lot. Yes, please.
XDCR is the replica in the
Cross data center replication.
active? Can you read from
Yes,
it?
yes.
Right?
Yeah, you can read write. Cross data center replication, master, so you can update anywhere, and then typically the lost write wins.
And can you filter that replication?
What does
In terms of the documents that get
that gets replicated? I believe you can. I don't know for sure what the filtering mechanism is because teams do it within my team. So, good question. Especially since I couldn't give you the exact way to do it. Anything else? Yes, please.
what kind of analytics do you run on top of this?
Oh, on top of this. So if you look at read versus write, OLTP, OLAP, the world is very different. OLTP, it's easiest to stuff data in as a blob. Why do we parse it out, split it up? For the reads, to facilitate the reads. So OLTP, if you're going to read, you partition into columns and things. OLAP, you'll get from different data sources, even external feeds. Say, Symantec is part of security organizations. You get external data, you get internal intelligence data for certain things, and all of this is joined. So it's massive. It's the output. So typically in OLAP, you will have a lot of joins, a lot of aggregations, because dealing with billions and billions of records is meaningless because you can't conclude anything from that. You have to roll it up. Who bought more shoes for the month, men or women? Men from New York or from San Francisco? So you get to larger, coarser as you go further away from the time zone, time of activity. So OLAP, a lot of roll-ups and a lot of machine learning. So we try to segment by features, look for the significance, correlations, causations, if we can tell. It's a big data system. So, did that answer the question?
Yeah, I was curious if you physicalize that data or if you do it on the fly.
Oh, so whether it's stream or batch, is that the question? So we do some, so stream is some activity is on stream. Like when an event comes in, you will enrich. You remember the information model we talked about, you look up, you enrich. This is happening to so-and-so. You enrich the data, and you act in line or near real time. Sometimes even after 3-4 minutes, you can tell the machine, hey, we didn't know at that time. We did a bit more analysis. The file that got dropped was a virus. And if you have endpoint protection, it has been watching. So the quick response usually is going to say, it is a virus, not sure. If it says not sure, the endpoint protection is watching the file, preventing it from doing IO fencing it in some way, watching the file. Once it's been, then you get a more authoritative answer. We detonated this file on, say, so many hundreds of VMs. So that is streamed. The machine learning is batched. So for a bigger volume, you go into batch.
When do you use the messaging versus the database? And is there any cases where you use the database for messaging, or do you stay away from that?
Typically, at larger scales, we stay away from messaging using the database because, as we mentioned, the trade-offs are very different. And one system, for the core security, it's a large scale. Typically, we stay away from the database as a messaging. Maybe for initial prototype, if someone's prototyping, I don't feel like setting up another messaging system, fine, proceed. if it takes wings when you are doing the real thing, go to a messaging system.
Can you say what messaging system you choose?
So we use RabbitMQ a lot. Yeah,
And how many messages per second?
lots. On different systems, it's a big number.
You won't say per node how many?
No, I cannot share that. If it's not, we have a very strict PR team, so if it's not already published, I will get into trouble. So, yes.
For the index issue, I'm not sure if it's a 3.0.
3.0. 3.0.
Okay, because I'm using 4.0.
You should see it fine.
Of still equals true or false. I just don't know if that's why it's using production. So if you set a flag of still equals false, then it does when you send the first request, it does rebuild the index before
Returning the index. But what's the setting? Scale?
Still.
Stale. Oh, yeah, stale. So we aren't using 4.0 in production, but yes, stale equals false will rebuild or not. And that setting is valuable. So 4.0, I like. It makes it more usable for us. Good point. Thank you. I didn't know the setting off the cuff.
When you embarked in the development of using Couchbase, did you find that as a result of picking it, were you able to basically get to market with your products faster than you would have if you would have used a typical database and so on?
I think the trade-off at that point was slightly different, to be honest. So you're always comparing development speed versus operational simplicity. Once I have it built, how much effort will it take me to run it? So Couchbase was more about the operational scale. So say, for instance, we couldn't use the secondary indexes, right? So we had to write extra code. But what we found was that the operational stability, multi-data center, I don't have to worry. One node going down, there's a replica. The speed, very high. Then the ecosystem brownie points. So those helped us. Probably about the same on development time, more on operational.
So it didn't hurt you?
Didn't hurt us, no. So we would have to use something to populate, say, with Elasticsearch. We would have to do something to populate it with Hadoop. All those adapters helped us. So, very good. Thank you, everyone. I'll be here. So, thank you.